Okay, good morning, everybody, and I want you all to know that when I submitted my title for this talk, it wasn't the title that they put on it. That's on the technical program. They said my title was too long, so they shortened it, and it made me mad because I had a title that was far more interesting. I was hoping that half the room wouldn't get up and leave before the talk started. Anyway. I did this work with a fellow by the name of Taylor Chu, who was my summer student this year, and I think that the slide on the screen speaks for itself. This vial of gold was taken from a 5-gallon bucket of quartz that was collected by a prospector at one of the sites that I'm going to talk about this morning. A 5-gallon bucket of quartz weighs about 60 pounds. I'm not sure how much gold is in that vial, but it's got to be 3 or 4 grams. Scale that up 35 times. You're looking at like 100 grams a ton, roughly. Possibly less, possibly more. Anyway, the title of my talk is Some Old Gold Showings, a Granite Cupola, a Pegmatite, a Goldenville Halifax Transition Zone Codicule, a bunch of gold and silver too, and a radio-controlled flying drone. So there you go. And when you're talking to a bunch of old guys in the mining sector, unless you're talking about something in a bikini, you can't get a better reaction than something like this. This is what guys think is sexy and fun. So the regional area of interest is relatively close to Halifax. You can see that the shoulder on the west side of this study area is in the South Mountain batholith. On the east side, you have the Musquodoboit batholith over there, and in the middle, you have the Kinsack Pluton. So if you zone in on that area, this is what it looks like. The area that you see there that's orange is all Goldenville, and the dark gray is slate, of course, in between. And the Goldenville Halifax Transition Zone essentially forms the contact between these two. Now, the GHT, a lot of people don't really understand what it is. It's a series of, it's a relatively thin area, in a thin bit of strata. In most cases, it's about as wide as this podium, but it can be quite a bit wider. The two sites where we did our work were the Beaverbank gold showing and the Pockwock gold showing. Now, Bob just got through talking about the MIP. One of these sites was the subject of an MIP project. That was the site at Beaverbank. The site at Pockwock was not an MIP project. I work with the prospecting community, and I work with some people who have grants and some people who don't. So this is a second derivative image of the area, and you notice that I've got some areas on the map here that are labeled IBG. This is an abbreviation for inferred buried granite. Now, granites show up essentially as dead areas. You can see how the South Mountain on the far western side of the map area is relatively dead. And over toward Mount Uniacke, you also have an area that's relatively dead. But when you go to Mount Uniacke, you don't see granite there. The area is underlain by granite, essentially. The codicule is relatively easy to infer. And Beaverbank and Pockwock are here. We've got the South Mountain on one side, the Musquodoboit Pluton on the west, and the Kinsack Pluton in the center. Creaser in 1996, in the thesis that she did at Dow, she did some whole rock geochemistry on these granites. And normally these granites have pretty much their own signature. What she found was in the whole rock chemistry that the chemical signature for these three granites is essentially identical, which infers that they are essentially joined at some subterranean isochron, and they are essentially all the same body. So we'll join them together. I've got, I used some of the inferred information to infer where these contacts would be. The Coticule, of course, is over that. And this is the area where Mount Uniacke is, which is also underlain. I'm not really going to talk about Mount Uniacke too much, but it was found probably about 20 years ago by Paul Smith when he was doing some work there, that he found microscopic bits of tungsten in some of the ore from Mount Uniacke, and is relatively hard to explain other than the fact that it's underlain by granite. One of the things that you can see too in this, on this slide is the fact that Beaverbank and Pockwock are essentially joined by not just the fact that you have a Goldenville-Halifax transition zone set of strata that joins the two of them together, they are also both underlain by granite. So let's go to Beaverbank, have a look at that first. The area around Beaverbank is very close to the Kinsack Pluton. This is the study area here, and when the Pluton was in place, you can see that there was some cracking and some faulting around it, which essentially, I think right over here, you can see this is a fault right here. And on this side, I'll point it out over right there. And so you've got some faulting that takes place when the Pluton's in place. If we go in close and have a good close look at the area, essentially the Coticule runs along the edge. What I'm referring to as a Kinsack Pluton fault, I don't really know if it's actually called that, but that's what I'm going to call it. You have two old shafts in the area, which clearly are right at the intersection between the two of these. Now, the work that was done on that those shafts more than 100 years ago would have been done a long time before there was anything like a second derivative image to show where this fault was. So this is the area where the Beaverbank showing is. We have some new LiDAR that was done a couple of years ago. The areas here noted as Site 1 and 2 are where the shafts were, and you can see on the old LiDAR that, or on the LiDAR, that there are some old undocumented pits and trenches which are directly downstrike from the shafts. These shafts, by the way, they're actually not, you can't find them today as shafts. They've both been filled in. The area is one that Barrett Lumber uses to get lumber off, so they filled the shafts in years ago, but there's still a lot of scattered muck in the area, so and trenches, you know, very close to where the shafts were, so it's not too hard to identify where the shafts actually were within a few meters. So this is Site 2, the one that's furthest to the west. We have a bunch of trenches that we identified there, a few outcrops, some scattered muck all about, and a pile of muck. And in the muck, we found evidence of cross-veining in broken muck pieces. Now, this is very important. I'll get to this in a moment. At Site 1, pretty much the same thing. Trenches, scattered muck, a big muck pile, and the muck pile had Coticule in it, which exhibited pyrite, chalcopyrite, pyrrhotite, galena, and spessartine garnet. This is Ralph Stay. It was his project that we were assisting him with, and this is the muck pile at Site 1. Now, it's a relatively old muck pile, but one of the things that you notice about it, or you should notice right away, is that it's got stuff growing on it when there's no soil in this stuff. And why is that? It's because the GHT is relatively limey, so it promotes growth. So this is what the Coticule looks like when you find a piece of it and you slice it in half. It's kind of gooey and toothpaste-like. Along one side here, we see some veining, cross-veining, and in that cross-veining, we found galena. So this is another piece. This is what the garnets looked like down at the bottom. This is, relatively speaking, the strike. And again, we have a later phase of quartz veining. And we are interpreting that as this cross-veining as being related to the Kinsack-Pluton Fault. And in this particular piece, we also found lots of galena. So the galena in both of these pieces that I just showed are, and whenever we found galena, it was in the cross-veining. So we're pretty sure that the mineralization is related to the fault, where the fault intersects the coticule. And when Ralph was doing his work, he got a couple of fairly good numbers close to the pits. They were both silver numbers, which hence my silver reference in my title. And Ralph did a lot of till work as well. For anybody who knows Ralph Stay, they know what he's all about. He's a surficial geologist, and this is a shot of he and Taylor in the midst of a hole. I wasn't helping this day. I actually had a problem this summer. I was playing basketball last winter and ripped my Achilles in half, so I spent half the summer just trying to keep up to these guys in the bush. And this is a shot of all of the samples that Ralph took. Where he took them, he hit the area fairly hard, and but most of the only really good numbers that he got were out of those two shafts, those two silver numbers. Another area of interest, which is within his area, was a number of almost 800 ppb gold, which came from up near Grand Lake that George O'Reilly got several years ago. It's known as the Grand Lake showing. The number came from a mineralized boulder, which was in a piece of muck from a trench. This is the trench right here. And the piece of muck came from about halfway along. We went in and had a look at this area as well. There's a quartz vein in there that kind of pinches and swells along the length of the trench. This is what it looks like. There's the quartz vein right there. And that's what a piece of it looks like if you find a piece of it. And from what Georgia described to me, this may actually be a piece of whatever it was he was analyzing. So if we go from Beaverbank now, we'll head down toward Pockwock, but we'll stop halfway along and have a look at the coticule so that people know what it looks like. This is what it looks like. Rick Horn actually told me about this site, fairly easy exposure to see on the side of Route 1. What you see there is all of the dark stuff is a little bit of mossy stuff that's growing in a lot of these funny little toothpaste-like structures that, you know, it actually attracts growth, so that's why the stuff is growing in there. If you clean it off, this is what it looks like. That image there is about as wide across as my hand. And in this particular site, you know, we talk about the GHT being relatively thin, but in fact, at this particular site, it's about 20 meters wide. Now, there are bits of it that are as wide as this, and then you get some relatively sterile gray wacky, and then you get another thing that's as wide as this, and some more gray wacky, and then something that's as wide as my hand, and some more. And the bottom line is, you have a relatively, in places, it's a relatively wide zone. And this is mineralization about 20 meters away from where that last photograph was taken. And clearly, you know, you have a relatively high thermal gradient going on from the granite that's probably underneath. This rock actually may be coticule, I'm not sure, but it was about 20 meters away from where that last photograph was taken. Okay, from Beaverbank now, we'll go all the way down to Pockwock and have a look at Pockwock. This is where this gold came from, was from the Pockwock site. Okay, now I would be remiss if I did not address the fact that, you know, Halifax's water supply comes from Pockwock Lake. And when you mention to people that, you know, there's a gold showing out of Pockwock, they say, what are you doing work out there? You know, you're never going to get to work out there. My God, the city's water supply is out there. Water! Hair on fire! The fact is, in reality, the project is almost 2 kilometers away from the Water Commission's boundary, and the lake is about another 300 meters beyond that. In comparison, the leachate from the former Sackville dump site is about 150 meters closer to the lake. So think about that. The leachate is closer. And this is what Pockwock Lake looks like. The leachate is way down here. Actually, I'll go backwards here. You can see right here, this is the former Sackville dump site right here. And the little black ponds at the bottom right there, those are the leachate. So there's the dump site right there, and there's the leachate right here. So there's the leachate. And the Pockwock gold showing is right here, so you can decide for yourselves which one's closer. If ever there was any reason for anything to get into the water supply, if it could somehow happen, there is a watershed in between the Pockwock gold showing and the edge of the city's water supply. And stuff would have to run downhill for a kilometer, more than a kilometer, to get to the Wrights Lake watershed, somehow poison the watershed, and then run uphill for 400 meters to get into the watershed for the Pockwock water supply. I should mention also that I don't have a profile for the leachate, but the leachate would have to go much further, but it wouldn't have to go as high to get into the other side. So I think I've excuse me, I think I've probably put that argument to rest. Okay, so when we got out to Pockwock and we were working out there, there was the Prospector, Corey Barkhouse had done some trenching out there, and essentially what we saw was a relatively messy, jumbled site. It was a piece of private property that the owner had taken most of, if not all of, the marketable trees off the property. There was some garbage trees left behind, and essentially what we went into when we went in there to map was a lot of broken slash, some trees all over the place, boulders, colluvium mixed with overburden, and it was a hard site to actually map. So this is what the site actually looked like. If you saw it in the foreground there, that's pretty much outcrop. That's as close to outcrop as we saw, really. We cleaned some areas off with brooms and brushes and stuff. But that's outcrop right there in the foreground. And then, you're dealing with stuff like this, piles of slash, muck, colluvium. You can see the quartz body there in the background. And so since we had a hard time figuring this out, we actually mapped it as much as we could, and then we enlisted a little bit of help. So this is our help. We have a radio-controlled helicopter here. It has it has a GPS mounted on it, and it'll fly a predetermined course if you want it to. Underneath, it has a GoPro type camera, and I knew people would come to me after and ask, what did this thing cost? And the cost for it was about $1,000. The camera was bought over the internet, was about $60. And the GPS is between $50 and $60 as well. So it's of course you should factor in the cost that you're probably going to crash a darn thing unless you have a pilot who can fly it. And this particular individual did a pretty good job for us. And of course, the cost for fun was priceless. So this is the area, what the area looked like when we imaged it. We got back a couple of hundred images, took the thing up to about the height of a 12-story building at times, and then brought it down and flew it over the area at about 50 feet. I think we got back about 200 images, just flew around for about 10 or 12 minutes. And these are some of the images that we got from flying at a higher height. You see three little shadows there. Those are the geologists. This is the area where the quartz that was shown in the first photograph was found that returned gold. We have a bunch of shafts all over the place. Most of these are still there. The one that is close to the place where the quartz was returned, however, that one's been filled in because that's very close to the entrance road to the pit. So that one was filled in years ago. The others are still in place, however, but they're caved in, of course. And strike is this way. We have a granite body that's relatively close by, and that granite body is given rise to a quartz body, which is interpreted as being the center silica body that is enveloped by pegmatitic leucocratic rock. So one of the first places we'll just have a quick look at so that you can see how the helicopter helped us figure this area out is this area right here in the center. This is what it looked like when we got our images back. You can see some quartz along the outside of the thing. We could tell that something was going on here, but we couldn't really tell because the area wasn't flat the way it appears on this image. It was there was some topography to it and a lot of jumbled rock and everything, and we couldn't really see very well, but we could see that there was some quartz right along here. Once we got the image back, we interpret that as being a series of tension gashes. And this is what it looked like on the ground. So clearly, you know, you can't really see any structure in that. I mean, you can see little bits of structure, and as you walk around it, you can tell there's something going on, but it really is just a lot of leucocratic rock with some quartz on the outside, and it was really quite hard to figure it out without the little helicopter. In the center of the pit, this is just an example of how good the imagery was. You see the three geologists there, and over in the northeast quadrant there, you can see right here, there's a small vein there, which we would never have seen if it wasn't for this thing. We wouldn't actually have found it. I'll take it away and I'll show it to you again. It's right there. Okay? So when we got up close to it and had a look at it, this is what it looked like. You can see some areas here where they're kind of scabbed off a little bit, so it looks a little bit thicker. But in fact, it's really only a centimeter or two wide. And we were able to pick that up from 50 feet with that little camera. Okay, over in the eastern section, we've got, we had a good close look at this as well. Over here, you can see that right there, we've got a survey picket, so we had some ground control. And that's a survey flag right there, that orange dot. We've got an area of iron alteration we were looking at. The strike is right here, and right over here we've got a shaft. We went over and that shaft was cleaned out by the excavator that was doing the work. Strike is this way. It's about 1 meter wide, and the reason why it was made, that wide, it was a little bit wider than 1 meter, was because there was a quartz vein on each side of it. So we sampled that vein along with a few others in the pit. And the quartz body is also extremely interesting. I'm kind of into pegmatites, so that sort of distracted me a lot. I didn't get nearly as much work done around this thing as I would have liked, simply because I just had so many physical challenges this summer, but I'm hoping that next year we can get in and do some work to the north of this where it hasn't been touched. South of it, you can see leucocratic influence from around the quartz body, but no one's done anything north of it. And I suspect that there is a very good chance that there are elements there that may be of great value related to this thing, because this quartz body is relatively wide. This is a shot of Corey Barkhouse standing in the zone, and the quartz body here is all drawn up in red. You can see that you've got some leucocratic subcrop in the area as well. This is what the leucocratic rock looks like. It's essentially a stockwork in a leucocratic ground mass. And this is, sometimes it has a lineation along strike. And you've got a quartz stringer stockwork related to this stuff. This is an outcrop, same type of thing. And you can see that you possibly have two different phases of quartz veining because some of it seems to be quite massive and some of it invades the host as a stringer stockwork. Okay, so we've got these underexplored environments here with the cotacule granitic underplating, so we've got a high thermal gradient, and we essentially have reactive strata that are modified by structures on structures underlain by a granite cupola. So next year we intend to go back, have a closer look at the fault north of the Kinsack Pluton. I want to try to do some work north of where that granitic body is, so that we can explore whether the pegmatite at Pockwock is carrying any lithium or tantalum or niobium, any of the elements that Mr. Bubar over there might be interested in. Okay, so that's my talk. Thanks very much.